Assalamualaikum and salam sejahtera. Today we are going to present our proposal for AI Research Laboratory. But before that, let's get to know to our team members. First we have Usaini, Adam, Akil and me myself Shazaril and also AC Fernandez. So first, let's get to know to our client overview. Who is our client? Our client is an AI research laboratory. This organization focuses on researching and developing artificial intelligence technology. Their team consists of AI researchers, data scientists, and software engineers who work on projects involving machine learning, deep learning, computer vision, and other advanced AI applications. So, what are the problems they intend to solve? The main problem they are trying to solve is the need to train complex AI and machine learning models. This model requires a large amount of computing power and time to process. In addition, they need to process massive data sets efficiently because AI researcher depends on analyzing large volume of data. If the system is too slow, it can delay experiment and reduce overall research productivity. So what are the requirements? To meet these challenges, the laboratory requires a powerful and reliable computer system. First, they need a high-performance multi-core CPU to handle multiple tasks and complex computations simultaneously. They also require a dedicated GPU because AI model training rely heavily on parallel processing, which GPUs are designed to perform efficiently. Furthermore, the laboratory needs fast and reliable networking to transfer large datasets quickly between researchers and servers. Finally, the system should be scalable and upgradable, allowing future hardware upgraded as AI technologies continue to evolve. I will let my colleague to explain more details.
Here are three best processors for AI research laboratory. First up, we have the NVIDIA Blackwell. There are two, which is the B200 and also the GB200. Each GPU features 192 gigabytes of HBM3E memory, around 8 terabytes per second of memory bandwidth, and delivers up to 9,000 teraflops using FP4 precision. It is designed for massive AI models. Blackwell GPUs are commonly deployed in DGX B200 systems with 8 GPUs, which provide over 1 terabyte of shared high-speed memory for large-scale training. Next up, we have the NVIDIA H200. It is a predecessor of NVIDIA H100. It offers 141 gigabytes of HBM3E memory with significantly higher memory bandwidth than its predecessor, which is the H100, making it excellent for training and inference workloads. Another advantage of the NVIDIA 200 is its capability with existing H100 software, allowing organizations to upgrade with minimal changes while supporting models containing hundreds of billions of parameters. And finally, we have the AMD EPYC 9965 with 192 cores and 384 threads, 12-channel DDR5 memory, PCIe 5.0 support, and exceptional memory bandwidth. It efficiently feeds multiple GPUs with data, which makes it an ideal processor for AI servers requiring strong multi-core performance and excellent GPU scalability. Thank you.
Let's talk about our memory design, powered by 128 GB of DDR5 RAM. The benefits: this high-speed RAM let us run massive AI models and process data incredibly fast without any system lag. We also use L1, L2, and L3 cache to cut down delay and keep our processes running at peak speed. The ROM. Lastly, ROM safely stores our startup firmware, so the system boots up reliably every time. Next up is our storage design, where we combine speed with high capacity. Primary storage, SSD. We use a 2 terabyte NVMe SSD as our main drive. It gives us ultra fast speed for loading datasets and saving our work. Secondary storage, HDD. For backup, we have an 8 terabyte HDD. It's a cost-effective way to store huge archives that don't need daily access. The big picture. By pairing an SSD with an HDD, we get the absolute best of both worlds, maximum speed and maximum space.
Let's look at the computer architecture. The system starts with input devices such as the keyboard and mouse, which allow users to enter command and interact with the system. The data is then processed by the CPU, which execute instruction and coordinate all system resources. Next, the system bus transfer data between the CPU, RAM, storage, and other hardware components. The RAM temporarily stores active programs, AI models, and datasets so they can be accessed quickly during processing. Meanwhile, the SSD and HDD provides permanent storage for datasets, AI models, software, and research results. Finally, the process information is displayed through output devices such as monitor, allowing users to view AI training progress and results. Now let's move on to the performance consideration. First is processing speed. A high core power CPU supports parallel AI workloads, reducing processing time. Second is reliability. The CCM helps detect and correct memory errors, ensuring stable and accurate system performance. Third is cost effectiveness. The selected hardware provides sufficient performance without spending on unnecessary components. And lastly is scalability. The system designed to support feature upgrade, including additional RAM, larger storage capacity, and a more powerful GPU as research needs grow.
And finally, we will talk about future improvement that our client can consider for their system. First, they can upgrade their RAM from 128GB to 256GB to double their performance on machine learning workload. Secondly, they can add one more dedicated GPU, such as RTX series, that is dedicated for the workstation, such as RTX A series. Lastly, they can implement a network attached storage (NAS) system that provides centralized storage, data redundancy, and automated backup for their local AI research database. In conclusion, our recommended system has met their requirement on AI research laboratory, as it contains higher core CPU count, bigger storage for their backup and archiving on database, and most importantly, high amount of RAM for their machine learning process workload.